say that if you have a dream, the universe provides. And I must say the universe has provided us here tonight because of the Rosetta Mission and the things that have been broadcast in the last day or so. So some of the material here was actually, I copied off the web yesterday morning, so this is really breaking news. Only it's not your usual breaking news because it is critical of the news. Before I give you those news headlines, which you can see flagged by the image here of the comet 67P, I'll give you a little bit of introduction. As all of you know now, Dave Talbot, Don Scott, Ev Cochrane and I got our initial inspiration from Velikovsky's thesis that the solar system has a recent dramatic history and that unimaginably powerful electrical events were observed in the heavens by modern prehistoric humans. The evidence for this is now overwhelming. My own passion since reading Worlds in Collision in the 50s has been to understand the science needed to explain the mytho-historical evidence assembled by Dave, Ev and Eduardo Cardona. Eduardo is not with us at this workshop, but his voluminous research and treatment of evidence is a must-read. It's difficult these days to keep up with the pace of new discoveries across all the sciences, but it's necessary due to the electric universe's interdisciplinary foundation and the fact that a real cosmology must be more than mere astronomy and mathematical speculation. So it's satisfying to see increasing numbers of scholars, engineers and volunteers willing to join the Thunderbolts project. The principal aim of this Electric Universe workshop is to inspire and encourage those who may become future leaders in this great adventure. Some say it is perhaps the greatest adventure in history because by recovering the real history of mankind, we gain a clearer view of ourselves and our place in the universe. And that clearer vision shows the powerful role of electricity throughout the universe. I can't stress enough how important that is for our future in this electric universe. So welcome all to the adventure of the electric universe. Robert Sterneman, just a moment. Robert Sterneman says, of all the forces we know, there is none stronger than a paradigm. And now we have the power of supercomputers to reinforce a paradigm through virtual reality, to the extent that it enshrines established myth and blinds us to other possibilities. Nowhere in science is this more evident than in astronomy, where a modern creation myth has been forged. Science has made the fundamental error of discarding myths only to produce new ones. The fact is that science can learn a great deal from myths, and mythologists can learn a great deal from science. That has been the foundation for the Thunderbolts project. Here's a topical example of computer-generated mythology on behalf of the European Space Agency for the Rosetta Mission to Comet 67P Churyumov-Gerasimenko. It shows that the aim is to confirm what we already believe. It is not testing a hypothesis. It isn't considering any alternative. So the data will have to be force-fitted into the myth. That isn't science.
Once upon a time.
Really?
This is a good one, I promise. What is the key to life on Earth?
Water.
Water. For a long time, the origins of water, and indeed life on our home planet, remained an absolute mystery. So we began searching for answers beyond Earth. Where could all this water have come from? In time, we turned to comets. 1 trillion celestial balls of ice, dust, complex molecules left over from the birth of our solar system, once thought of as messengers of doom and destruction, and yet so enchanting If we were to catch one,
so there's the myth. Of course, the electric universe version is wildly different and more interesting, as you will learn over this weekend. And the electric universe story has been able to predict surprise after surprise from space probes, particularly comet probes. This is crucial to verify the insights of the pioneers of the electric universe, Ralph Jurgens and Dr. Earl Milton, who proposed the basic model of electrical interactions between a comet and the sun back in the 70s. Now, what follows is a brief statement from Jean-Pierre Bibring, lead scientist for the Rosetta lander, which shows the overwhelming attachment to the myth of icy comets in the face of images of a comet that looks like solid rock. Oops, sorry, wrong way.
There is no ice at the top, so it's covered by a mantle that we consider is essentially made of organic material. That's why it's very dark. And this material is one of the key things we would like to explore and analyze.
There is no ice on top, so it must be buried under a thin crust. Have you noticed how many astronomical mysteries are buried out of sight inside stars, planets, moons, black holes, where you can speculate all you like and postulate anything you like? But I have some sympathy for Jean-Pierre because he has been misled by his teachers and colleagues into thinking that the mass of the comet equates to the amount of matter in it. Of course, because the measured so-called mass of the comet suggests that it has only about a tenth to maybe 0.25 the density of water. But mass does not equate to the amount of matter, as I'll discuss in a later session. Eyesight is our most important sensory input in science. If the comet looks like a tortured rock, then that should be the first assumption to act upon. We've had plenty of prior warning from looking at earlier comet nuclei. But such is the power of the paradigm that we are incapable of seeing what is right before our eyes. It's a case of it's not the things you don't know that cause the problems, it's the things you don't know you don't know. Before dealing with Comet 67P, where are we here? I've done that one, sorry. Here we go. Let's just go back and see what was found in the very first comet samples from the Stardust mission. It was full of surprises as usual. In the Science Journal of the 25th of January 2008, Richard A. Kerr reported that first, not a single speck of unaltered pre-solar material was found by the Stardust mission. 2, Wild 2 seems more related to asteroids than comets, said cosmochemist Larry Nittler. 3, it's changing the way we think about comets, said John Bradley of Lawrence Livermore National Laboratories. But it hasn't changed at all, as you can see from the earlier material. Stardust chief scientist Don Brownlee said, rather than preserving the original ingredients of planets, Wild 2 seems to be loaded with materials first altered by the great heat near the young sun. It doesn't seem to occur to these people that they've always thought the planets were built from comets. It never occurs to them that comets may have been built from planets. Comet theory hasn't changed one bit. It hangs on to the solar nebula model, but now with an ad hoc, mysteriously modified composition to match the data. Because here they shoveled the hot material from near the sun out into the outer reaches where it could be incorporated into comets. This is a pretty messy kind of theory. But Comet 67P here from 10 kilometres distance looks nothing like an ice and dust aggregate. It looks like a piece of a rocky planet, which is what I said some weeks ago on the Space News on the Thunderbolts website. And note the bright spots up here towards the centre of and upwards a bit. The electric universe model of comets says that comets are complex bits of planets, as you saw in that graphic from Dave Talbot earlier. the conjunction of two planets, if they come close enough, the electrical effects are to strip part of the surface into space. But talking of bright spots, here's Comet Hartley 2 in 2010. The comet rotates every 18 hours. It was reported, before I do that, I'll go through this list here. This is some of the things that were found. The jets seem to be issuing from those bright spots. The bright spots seem to be atop boulders or surface projections, not fissures. The bright spots are generally featureless, not just high albedo surfaces. And the jets issue orthogonally, that is vertically from the surface. Some jets on this comet you can see are on the dark side, and one jet there where the arrow is seems to start and stop abruptly. All of these are simple effects that you would expect from an electrical discharge, but not from material issuing from inside the comet through odd-shaped vents and fissures. It was reported also the amount of water changed dramatically night by night, and even within a single night in some cases, doubling in that time. What surprised the researchers was this: as the amount of water went up, so did the amount of the other gases. And as the amount of water went down, the others did too. The fact that the gases all vary together is somewhat puzzling, because a large variation was found in the release of carbon dioxide relative to water, said the head of the science team, Michael Ahern. Researchers think that chunks of water ice are glued together in the comet's core by the frozen carbon dioxide, which evaporates before the water ice. The carbon dioxide gas drags with it chunks of ice, which it later evaporate to provide much of the water vapour in the coma. This is an extremely complex model and ad hoc. In the electric universe model, the gases in the jets are produced by spark machining of surface materials, surface minerals rather, so the gases all vary together. The variation in carbon dioxide relative to water could be expected from the movement of discharge points or jets on a non-homogeneous comet nucleus. And it is that same surface electrochemistry that may account for the extremely blackened surface. It may be hydrocarbons or even carbon itself, but it doesn't have to be. This is an opportunity for garage experimenters to test using clay and rock as the target for a discharge. So here are some of the very preliminary findings about Comet 67P that were announced early yesterday morning at a press briefing at the landing of the craft that was supposed to fix itself to the comet's surface.
Hi, Eric Ham with Science Magazine. I was hoping to ask a question, I guess maybe for Jean-Pierre or maybe Holger, a geology question. We're getting slightly conflicting information. We were told upon landing that we landed in very soft stuff. And we see from the Rollers picture, this very soft stuff with mobilized dust right in the middle of Site J. But then we see these Shiva pictures maybe near a cliff wall and things that really do look like rocks. So I was hoping one of you could explain what these materials are and how they can be explained by being made by comet processes. Thanks.
Okay, what you are asking for is to try to be 1 year ahead of us, because we make this mission essentially to answer the question you're asking now. So it's normal that we don't have the answers, and probably the answer would demonstrate that the question is not really well formulated. When you say a cliff, for example, it has some resonance in our head that a cliff is terrestrial sort of cliff analog. We don't think that we're that sort of cliff, because the material is very low density anywhere. The density is less than 0.5 globally. So the idea of having a very porous material at the very top came from that, to the idea that there is no reason to believe that the crust is really a strong crust, as we thought in the past, on a very low density material there. So that's why we thought that finally, with the first images we had, plus the Cosima measurement showing that the floating grains were very fluffy, very porous, that we might have that when we landed. We are not saying that actually it's not the case. It might still be the case. You might still have some really fluffy power, out of which you are, after rebouncing again, the ejection velocity is very low there. So I would not be more accurate that what we have found does not demonstrate that we don't have a crust. It does not demonstrate that it's a crust. Are you satisfied?
Thank you,
So I'm
Jean-Pierre.
really happy with you not satisfied.
So I would follow you on that thought that the rebounds of the lander is an indication of a higher strength material. That was a surprise to us. So with this picture of dust falling back to the surface, building high porosity layers, I would think we failed to explain the rebounds. So, but we have seen the variety of surfaces there, this snow-filled soft stuff, and we have seen this rocky-like but no rock stuff, which is perhaps a higher strength material. We also see stuff shining through a dust layer where the dust is wiped away or following the gravity field and exposing a higher strength material. And this is something that we could consider be the reason for the rebound. So bounce in there, find a higher strength material, and then get going for the next landing.
So there you go. It was low density everywhere. This is the big hang-up. There are two things about that. One is that gravity is not understood. I'll be dealing with that later in the weekend. All we have is a mathematical description, which is no help in understanding. Also, there is the possibility that the comet may have a hollow center. Also, the floating grains were very fluffy. Well, electrical ablation of surface minerals can cause that. A higher strength material that was a surprise to us, based on this erroneous assumption that mass equals the quantity of matter. With this picture of dust falling back to the surface, forming high porosity layers, we failed to explain the rebounds. Well, dust is being removed from the comet and moved around electrostatically, as it is on the moon. It's probably superficial in most areas. It's rocky-like stuff, but not rock, because it's impossible according to the very low density estimate. This aspect is central to the electric universe explanation of gravity. Mass is not equal to the amount of matter, a fundamental error in physics. The electrical model, as I said, even suggests hollowness. And then there was this interesting thing that was said, we also see this stuff shining through where the dust layer is wiped away or fallen off following the gravitational field and exposing a higher strength material. And this is something we could consider could be the reason for the rebound. Well, the shining stuff may be the coronal discharges from the comet. If so, there will be featureless glows like St. Elmo's fire, perhaps with bright points at the active cathode spots, leaving behind a darker, blackened surface that had been modified electrochemically. Anyway, congratulations to the Rosetta Mission team for a fantastic effort. Shame about the science mythology. It was interesting, the following morning there was an ESA blog where a geologist posted the following comment. And since it was an ESA blog, we had to log in. I assume he was somewhat of an expert. He said, it looks like the shrinkage patterns of clay on the surface, and this is the image from the lander looking at the surface nearby. It is quite possible that clay is among the most abundant minerals on the panoramic landscape of the comet. Well, this is a pretty outrageous thing to say because clay includes pyroxene and olivine, which are high temperature minerals. Also, to make clay, you require water and a more or less a planetary environment. He says it is this form of clay is quite common in nature here on Earth. He said weathering causes erosion of topographic highs and their deposition in basins, shallow seas and oceans. The effect of heat and pressure change the minerals like olivine into clay and even cement, and in the process captures and sequesters atmospheric carbon dioxide. This last point is interesting too because that could be the source of carbon dioxide as well as the water in the comet coma. So we switch to the Mars MAVEN mission, which ducked out of the way when that comet shot past just recently. Comet Siding Springs flyby, which was 87,000 miles above the planet, or about 140,000 kilometres. Debris from the comet added a temporary and very strong layer of ions to the ionosphere, the electrically charged layer high above Mars. This was the report. Such an electrical disturbance is expected from an electrified comet with a different potential to that of the planet. And the closer the approach, the more severe the electrical effects, up to a Tunguska-type event or worse. In more recent news, it calls into question our beliefs about how planetary systems form. The caption for this artist's rendition says, "Astronomers have discovered an exoplanet that is 10 times as heavy as Jupiter, but orbits its star in less than a day. However, such a sighting should be a relatively rare occurrence, suggesting that physicists may have to reconsider their understanding of how stars interact with their planets. The existence of huge Jupiter-sized planets so near to their stars is a long-standing puzzle, since they cannot form near to the star where it is far too hot." So the standard response is to say they must form much further out, where it is cool enough for ices to freeze out of the proto-planetary disk, this hypothetical proto-planetary disk circling the young star, hence forming the core of a new planet. And then something then must move the planet into a close orbit, and one likely mechanism is an interaction with another planet or star. Well, it was the astronomer Tom Van Flanten who showed how unlikely these kind of occurrences are. So this is a highly speculative and unlikely scenario. And given the number of hot Jupiters discovered, this last point seems strained. What's worse, exoplanets have been found orbiting backwards and over the poles of the star. The electric universe model of star and planet formation follows the plasma cosmologists, which is all peer-reviewed material, whose theory has been supported by recent infrared images of stars formed along glowing Birkeland current filaments in molecular clouds. As Hans Alfvén wrote, gravitational systems are the ashes of electrical systems. But the electric universe models adds an electrical fissioning mechanism for forming hot Jupiters like this one that results from a new understanding of the electrical nature of stars. This planet may be recently born instead of facing annihilation by crashing into the star, as the article later suggests. And this recent report shows the dogged application of the myth about planet formation from a dusty nebula. It says, "These dusty disks, likely created by collisions between leftover objects from planet formation, were imaged around stars as young as 10 million years old and as mature as more than 1 billion years old. It's like looking back in time to see the kinds of destructive events that once routinely happened in our solar system after the planets formed." This is the kind of response you get from one of the scientists. Here we see the myth of solar system history stated as fact. But no two disks of material surrounding stars look the same. The report says the features around the star HD 181327, which is the one on the right top corner there, resemble the ejection of a huge spray of debris into the outer part of the system from the recent collision of two bodies. But when all you have is gravity and explosions, your options are extremely limited. The disks look far more like corona discharges, which you can see below there, which makes sense if we're looking down the barrel of a stellar Z-pinch, which is something that we'll be discussing in more detail, and especially after Don Scott has given his presentation. Also, we only hear of accretion disks, yet stars regularly expel matter, so the notion of expulsion disks should be considered also. And here we have problems with stellar evolution theory, and it's a recurring theme in science reports over the previous months. But here's the latest one about stars in globular clusters. It's generally believed that all stars belonging to the same globular cluster were born together from the same interstellar cloud and at the same time. Strangely, however, this is not the case. It appears that the more information astronomers acquire about the stars in Omega Centauri, the less they seem to understand the origin of these stars. The evidence discounts the stellar evolution model. Globular clusters have multiple main sequences. This is pretty odd. Two groups of stars with either an age difference of 1 to 2 gigayears or a significant difference in their carbon, nitrogen, oxygen content and a difference in helium abundance. Astronomers found that the bluer stars contain more heavy elements than those of the redder population. Now, these are all supposed to be the same age. This was exactly opposite to the expectation, and they are led to the conclusion that bluer stars have an overabundance of the light element helium. They are, in fact, the most helium-rich stars ever found. But why is this so? The team suggests that this puzzle may be explained in the following way. First, a great burst of star formation took place during which all the stars of the red population were produced. These stars transformed their hydrogen into helium by nuclear burning. This is a standard story. Some of them, with masses of 10 to 12 times the mass of the Sun, soon thereafter exploded as supernovae, thereby enriching the interstellar medium, but blasting it everywhere, in the globular cluster. Next, the blue population stars formed from this helium-rich medium. This is really a crackpot theory when you look at it. It's incredibly unlikely and complex. It's not been shown that the dispersal of heavy elements by supernovae can be enough to form second-generation stars in significant numbers. The EU says, the electric universe model, there's a tight alignment of the normal vector to the disk of globular clusters with that of the disk of satellite dwarf galaxies, so they're tied together in some interesting way. They seem to have had the same birth process by ejection from the core of the galaxy, based on Halton Arp's observations of ejection of quasars or nascent star clusters from the galactic core in the plane of the galaxy. And this meets neatly with plasma cosmology models of spiral galaxies. So globular clusters appear to be a form of nuclei of dwarf galaxies. I won't go on about the stellar ages and composition. The electric universe model of stars shows it to be incredibly complex and untestable, and it is invalid.
When I got the news on April 23rd, earlier this year, that a flare had been detected by SWIFT, and it was coming from a nearby flare star called DGCVN, I was initially very surprised. SWIFT doesn't normally detect flares from nearby flare stars, and DGCVN is a relatively unknown star.
There are a few things we know about DGCVN. It is an M-class star, also called a red dwarf, and is located only about 60 light-years away.
It's a dim little red star. It has a luminosity that's about 1,000th the luminosity of the Sun. It has a mass that's about 1/3 the mass of the Sun, and a radius that's about 1/3 the radius of the Sun.
The largest solar flare ever recorded happened on November 4th, 2003. It was so powerful that it overloaded the sensors measuring it, but later calculations put it at an X45. Flares are classified according to their strength. The smallest ones are B class, followed by C, M, and X, the largest. An X45 flare is a very powerful flare. DGCVN's flare, however, was much larger.
We can estimate how big the flare on DGCVN was with respect to the solar scale. It would have been an X100,000. So this is several orders of magnitude larger than the biggest solar flare we've ever seen. The flare that SWIFT triggered on from DGCVN was only the beginning of what turned out to be a fairly extended series of flares, a flare event, if you will, that lasted almost 20 days.
This was a very different star than the Sun, so we don't really have to worry about this happening in the present-day Sun. the young sun, such large events may have occurred. In the present-day sun, the activity levels are much lower. And the fundamental reason that DGCVN is more active in the sun is it's a very young star, 30 million years. It's rapidly rotating. Young stars are born that way. And rapid rotation is one of the key ingredients which powers activity. The faster the rotation, the greater the activity.
While not a threat to us, the massive flares of red dwarf stars can help us better understand the flares produced by our own sun. They are also of interest because red dwarf stars are often orbited by planets. Some data suggest that 40% of red dwarfs have super-Earth-type planets orbiting in a habitable zone, where liquid water is possible. If this is true, then they are good candidates for supporting life. However, the habitable zone around a cool, dim star like DGCVN is much closer to the star than the Earth is to the Sun.
When planets are closer to their star, they're more susceptible to anything the star does. For instance, if the star flares, the planet is much closer to the star and it can be hit by the radiation or the particles that get ejected from the star when this flare process happens. If you happened to be on a planet around an M dwarf when one of these large flares went off, you'd be having a very bad day.
I wanted to finish on this slide because this has significance for what we will be talking about when we discuss Proto-Saturn later on the weekend. Because all of the story about the ages of these stars and how they behave and that our own sun is not likely to do this kind of thing is based on erroneous science. None of it is valid. However, there are certain aspects that I just want to point out before my time is completely gone. The light curve that you saw there showed rapid onset and slow decay followed by lesser pulses gradually falling. And that's typical of lightning or an electrical discharge. Red stars don't have the photospheric granulation to regulate their discharge, so this is the only way they can respond to changes in their environment. And they do so by changing in size and by expelling matter. And I would suggest that that red dwarf was actually giving birth to a satellite. It may have been of planet size. I think this is the way in the electric universe that these things happen, and it has significance for the story of Proto-Saturn, which we'll discuss later. Thank you.